All right, so as I was saying, we are going to be doing dilations today on the coordinate plane, which is a little different than the ones that we did yesterday because we don't necessarily need to use a compass for these. Since we're on the coordinate plane, it's easy for us to use those squares, our grid, to help us just count spaces between like our center point and our letters. When you guys did the Desmos activity on Monday, there was someone in one of the classes, I can't remember who it was, and again, it was anonymous, so it doesn't really matter who said it, but somebody in one of the classes talked about with the dilations activity slope. They mentioned slope being kind of a thing. They actually, said slope in their answer for something, which was kind of interesting to me only because we haven't really talked about slope at all. But when you're looking at problems like this, you are using slope. So before we even get into it, what is slope? What do you guys remember or know about slope? Rise over run. What does that mean, rise over run? Okay, so she said go up for the rise. Is that what you mean? Could it also go down though? Yeah. And what does run mean then? Left or right. Okay, so kind of going back to what Anna said, she was talking about the x and y coordinates. The rise is talking about your y coordinates, like how much change is happening on your y-axis. The run is your x, how much is going on your x-axis. Okay, we're going to use this idea of rise over run to help us identify slope on these dilation problems. Now down below, there's a couple of different scenarios that they're providing us with. Some of them are going to have positive scale factors, some will have negative, some will be getting bigger, some will be getting smaller. And then you'll also kind of notice that they're giving you different situations of when the center is like moving around on the shape, what happens? Like where does it go? And like what does it do for your dilation? And you saw some of these yesterday on your homework when you're doing those constructions. You've seen examples where the center is outside of it, inside of it, on the shape. So we've seen this stuff already happen. I'm going to just kind of zoom in and start with this first one. This one has a slope. Not a slope. This one has a center that's on the outside of the shape. What letter is my center here? O is. So that point kind of right here is where we're going to kind of start our counting when we try to find our slope. Now, to find my slope, I need to think about that rise over run. So when I count from O to one of the letters on my triangle, I want to make sure I do rise first, which is going up or down first, and then my run, which is going left or right. So let's talk about O to A. If I'm starting at O and I want to get to A, I want to start with my rise first. How much does this rise? 2 squares. And how much does it run? 3 squares. So all I'm going to do over here is I'm going to write out what you guys just said. I'm going to say OA was 2 over 3. That's my original slope. It went up to right 3. Going up and going right, those are both positive directions. So I'm okay to just say 2 over 3. Now, if I go down or if you go left at all, make sure you think that that means you went negative, so you have to reflect that when you're writing your slope. What's the scale factor for this problem? 2. And what do we do with that scale factor in our measurement to get our new one? We multiply them. So if you take 2 times the 2 and the 3, you have to multiply both numbers by the 2. So you could write it if you want. You're going to take both of these times 2. What does your new slope become? 4 over 6. Okay, so I'm going to come back here. We always start counting from what point? In this case, O, because it's our what? Our center. So you're going to go from O up 4, 1, 2, 3, 4, and then right 6. Draw a dot there, and what are we going to call this point? A prime. Okay, and we're going to start over.
I'm sorry.
You're good. And we're going to do this now for O to B. What's my slope from O to B? Up 1 over 4. Again, we multiply by our scale factor. If you take those times 2 on the top and on the bottom, which if you need to, you guys can be writing that out, times 2 times 2, what's our new slope? 2 over 8. So from O, I need to count up 2 and to the right 8. And we call that one B prime. And we have one more point to do, which is OC. What's my slope from O to C? -1, because we had to go down, right? So down is a negative movement, and then over still to the right 2. So that's still positive. If you take those numbers times 2, what do you get? Good, -2, 4. So if I start at O, what direction should I go? Down 2 and right 4. And there's my C prime. Okay, and then you have all three points done. Now you just have to connect them. That's why I said maybe you still want to have a straight edge to do this, unless you're really great at freehanding straight lines. Okay, some of you might be. You can just now use that to kind of connect your 3 dots together to make your shape. Now we didn't draw in our projection lines for this problem. You could have though. If you guys find those projection lines helpful, you would just need to use your ruler or your paint stick, whatever you might have, and connect O to that A, and then just keep it going because you know it's going to get bigger. And so I'm just going to draw that in. But you can kind of see when these projection lines get drawn in here, they should line up with like your center and then the 2 points that you have, your A and A prime, B and B prime, and so on. I may not be drawing those projection lines in though, just because they're may be useful for like constructions like we did yesterday when we were just looking at a blank piece of paper. I don't know if they're necessary to include when we're on the coordinate plane because you are able to use those squares to count. But if you're curious if you put it in the right spot, those projection lines would help you know. It would be a really easy way for you to check if you did it right. Any questions on that first one? Okay, let's go to the next one. What letter is my center point? Still O. This time, though, it's on the inside of the shape. And what's my scale factor for this one? 1/2. So let's start again by finding our slope. So let's go O to A. How would you guys write slope for O to A? Why is it over 0? It doesn't move this way. We still need to reflect that, though. We can't just say 1 because then I don't want you to think when you go to do the next one that the 1 would apply to both directions. We're still thinking about rise over run. So it's good to keep that 0 in there. It just kind of holds that place for us. And then my scale factor this time is what? 1/2. So we're taking 1 times 1/2 and 0 times 1/2. What's 1 times 1/2? 0.5, which is the same thing as 1/2. Now, I do like to write it as a decimal, only because I'm graphing it. It's easier for me to graph decimals than to graph fractions. What's 0 times 1/2? 0. So I'm still not going to go left or right at all. Where do I start counting from? O, and I'm just going to go up 1/2. So just half a square. Estimate where you think that is about. You're not going left or right at all. And we call that A prime. And then we start over. OB, let's do that next.
0, 1.
This time it's 0, 1. Very good. Because we don't go up or down at all. We just go to the right one. If you take that times 1/2, what do you get?
0.
Good. 0 and then 0.5. And then I'm going to graph that point. This time I'm just going to go to the right 1/2. And there's my B prime. How about O to C? Very good. -2, -1. You're going down and left, so they should both be negative numbers. If you take those both times a half, what's my new slope?
1 over 0.5.
And are they positive or negative numbers? So from that center again, we always start counting from the center. You're going to go down 1 and then over a half. And that's your C prime. And then again, just connect those dots because we want to see that triangle in there. So it's pretty tiny. It's inside of that original shape. Anytime that the center point is inside of the shape, there's going to be some overlapping when it's getting smaller, like it's going to shrink and it's going to be contained inside of the original shape. If this was a scale factor of 2, it would go outside of that, but the original shape would be contained inside the new one. Any questions on those first two? Everyone feeling okay about it so far? Don't overcomplicate the counting process, but do make sure that you're going the right directions in the right order. Because the biggest mistake that I think we see students make is they count left or right first and then up or down. So they're getting their slope switched around, and then it can impact how you're doing your final answer if you're not going the right directions. So be really careful with that. And then also, like I said, make sure you're always starting at your center point. Even if the center isn't necessarily at 0, 0. Your center point is where you begin your counting. If we look at this third case, where's my center this time? It's the A. Is the center going to move at all?
No.
So is A going to change at all here for this one? No. So what I like to do when the center is on the shape is just right on top of it. I'm going to kind of just put another dot and I'm going to call it A prime right next to it. You had a problem like this on your homework yesterday where you had a problem where the center was on the shape and you had to do your construction with it. That one point, though, didn't move at all. It stayed there. So we don't have to do 3 sets of slope this time because A doesn't move at all. Instead, we need to just do A to B and A to C. So we get to cut this down by 1 step. What's my slope from A to B? And what's my scale factor this time? 1.5. So we're going to take them times 1.5. And so what's my new slope? Very good. So now let's go ahead and do that. We're going to go down 1.5. Again, since we're going half, you have to estimate where you're at. So you're going to go down a full square and a half more, and then you're going right a full square and a half. You're going to land right here in the middle of that square, and this is going to be where B prime goes. Okay, how about A, C? What's your slope? Is it +1 or -1? Good. And then we take that times 1.5. So what's my new slope? Anyone know what -3 times 1.5 is going to be? 4.5. Good. -4.5. And then the bottom would be just a -1.5. Again, anytime you're dealing with a decimal on the graph, you just need to estimate to the best of your ability where you think it's going to be. Again, we start counting from A. So starting back up here at A, I'm going to go down 4.5 and then left 1.5. And so there's my C prime. And then when I connect these shapes should overlap. So like this side, AB, should still be used. And then if you just extend it, it should hit your B prime. Same with AC. If I connect these, I just kind of trace over that and I keep it going, it should connect with my C prime. And then the bottom 2 letters should connect, and those should be parallel to that other side BC, because those are the only points that moved, and they did get bigger, so they moved farther away from that original triangle. Any questions on that one? All right, we've got one more kind of in this top section. What's going on here? This one has a negative scale factor. Okay. Now, in the past, when we've done this like on the number line problems, or yesterday when you guys are doing them with the constructions, the negative scale factor forced it to go backwards. Okay. Since we're on the coordinate plane though right now, when we take care of this negative scale factor, if you're multiplying your slopes by that negative number, it's going to make the change for you, and it's already going to force your points to go in the opposite direction. So you probably don't need to think so much about flipping like a compass around or making sure you're counting backwards, because the slope being negative or the scale factor being negative is already going to impact your slope, and it's going to force them to switch. Now, where's my center point at? O. So let's start counting slope from O to A. What would that be?
2, 2.
And then if I take both of these times -2, what do I get?
-4, -4.
So just take a look at the original slope being 2, 2, and my new one now is both negatives. That should make sense because a negative scale factor is going to force this thing to go in the opposite direction. So I had gone up and right. For my new one, I need to go the opposite directions, which would be down and left. But it's also getting twice as big. So that's why the numbers are increasing. Again, from O, I'm going to count down 1, 2, 3, 4, and left 1, 2, 3, 4. And this is my A prime. Okay, how about O to B? If we multiply both of those by -2.
-2, 6.
Good. So then from O, go down 2, left 6. And that's B prime. And last one here, OC, what's my slope?
-1.
Good, -1, +1. If you take those times a -2, what do you get?
1, 2. +2, -2.
Good. So up 2 this time and left 2. And there's your C prime. And then just connect those. Ooh, almost had it. Again, I'm not drawing in those projection lines, but if I had them in and I'm connecting, like the B prime, the O, and the B should all be on this same projection line. C prime, O, and C should do the same thing. And the A prime, O, and A should do that as well. And that looks more like what you guys did yesterday with your constructions. You used those projection lines to help you go the opposite direction. So those are still there. Like I said, I'm just maybe not drawing them in because I don't find them as maybe necessary or even maybe as helpful today as I did yesterday. Questions on that negative scale factor problem? Okay, so we've got one last thing to do down here. And this is looking at two shapes that have already been dilated, and they want you to figure out where's the center point that they were dilated around, and then also what is the scale factor? So what did they do to the shape to make it get bigger or smaller? If we just look at these, make sure you can identify the original shape to the new shape, and we do that by looking at the letters. So like this one that's smaller says A, B, C on it, and I will just say this one is missing its little prime marking. So you can just add that on there because that all the other ones have them, B prime, C prime, so that should be an A prime. So just take a look at this really quick. Does it look like this was a reduction or an enlargement? Okay, so since you can kind of see like the new shape got bigger, we should know that our scale factor should be greater than 1. So when we find our scale factor, if we're getting something like a half or a third or something that would be less than 1, we probably thought about this backwards. So you want to make sure that maybe you can check that first before you even start looking at the numbers. Now to find your center point, those projection lines are going to help us figure out where it is. Because remember, the center point, like when I drew it in back up here, that center in the middle is where all the projection lines kind of met at one single point. So I need to find those projection lines to help me find my center. To do that, using your guys' paint stick here, you can just connect down here. You can connect A to A prime and draw your projection line in. Now when you do that, make sure it goes like all the way through your graph, because all these lines that you're drawing in from like here to here and then B to B prime and C to C prime, you want to see where they're going to cross. So if you're not finding where they crossed, you didn't make your projection lines big enough. So you might need to extend them a little bit farther. So go ahead and take a minute and do that. I'm going to draw mine in as well. Okay, so we've got those done. Where do they all seem to meet at? Now remember, we're on a graph, so it's a coordinate. So 0, 2 is how I would write it for my center. So over here, I'm going to say 0, 2 seems to be my center point. Now to find my scale factor, let's do what we were just working with, and let's think about slope, because the slope might help us see how much it either increased or decreased by. We already talked earlier, though, that this is an enlargement, so we know we should be getting a number bigger than 1. So I would start by counting from your center point to any corresponding letters. That means you could choose if you want to go from the center to the A's or to the B's or to the C's. I don't care which one you guys do. Just make sure that you're consistent with both letters. You can't go to A and then go to C prime for the second one. That's not going to be any help to you. So let's just count from the center to my A's. So what's my slope from the center to A? Okay, and then this changed to center again. Now we're going up to A prime. How much was that?
4, 6.
So all you need to tell me now is what did they take 2/3 times to get it to 4/6? 2. So my scale factor would be 2. If this problem had been reversed with the markings, so if the smaller one had been the primes and the bigger one would have been the original, your slopes then would have been 4, 6, and then 2/3. Then you got to think about, okay, it shrunk, but again, we're not ever saying that we divided by something. We're always multiplying by scale factor. So I would need to see like a half. When you do your slopes, I would always count to the original shape first and then to the one with the prime marking so that you make sure you're setting up your slopes correctly. Okay? Anyone have questions on that last problem? All right.